if you look at the first problem, it wants us to find the key features of that function. So first we need to graph it. So plug in x squared plus 6x plus 8 graph. Now it looks like the roots are nice numbers. It also looks like the minimum is a nice number. Okay? The fastest way to check is to go to the table. So push second table. Are the roots actually integers? Are they nice numbers? How can I tell? Because I do have a 0 for the y value. So negative 4, 0 tells me that one of the roots is negative 4. Okay, and what's the other root? Negative 2. Can I find the y-intercept on the table? What am I looking for? When x is 0. So what does y equal when x is 0? 8. So my y-intercept is y equals 8. And then I can try to find the max or min. Is this one going to have a maximum or a minimum? Well, if I look at the graph, does this graph have a maximum or a minimum? Minimum. So we go back to the table. What is the minimum point? It looks like negative 3, negative 1. Can I be sure that that is the minimum? Can you look at the table and say, yes, that's the lowest number? Well, let's actually find it then. So everybody push second calc. We want to do number 3 for the minimum. So you can either plug in numbers or you can just use the arrow. So if I go to the minimum, it wants some number to the left. So I'll just go to the left a little bit, hit enter. Some number to the right of the minimum. So go over here to the right and hit enter. And then my guess will be right there. Now it says negative 2.999999, but what it means is 3. A lot of times the calculator tries to be smarter than it actually is. So negative 3, negative 1 is the minimum. Now if I look at the table, I could have figured it out here. How can I be sure that the minimum happens when x is negative 3? Just by looking at the table. Nobody knows? It's halfway between negative 3 and negative 1. Wherever your roots are will determine where your minimum is. So if this is your quadratic, so negative 4 and 2, my minimum has to be halfway between those. So 1, 2, 3, 4, 5, 6, which means the minimum would be right here at negative 1. So if I had one that looked like this, where is the minimum going to be? At 2.5. Would 2.5 show up on the table? No. So if your minimum is not at a nice number, you have to do second calc minimum or maximum to find it. All right, so going back. So this has a minimum value at y equals negative 1. There's a difference between minimum value and minimum point. The minimum point is negative 3, negative 1. But the minimum value is just negative 1. So minimum point includes both the x and the y, and the minimum is just the y. Okay? We now have enough information to graph this. So I'm going to graph the two roots, the minimum, and I'm going to graph the y-intercept and draw that. Good job. Is it? Oh, just make the lines bigger. Okay, so now we need to do domain range, increasing, decreasing, positive, and negative. All 6 of these are intervals, and 5 of the 6 deal with x values, and 1 of them deals with y values. Which one deals with y values? Right, the range. So when you're looking to fill these out, don't look at the y values, look at the x values, except for range. So the domain, if I draw a vertical line through the x-axis, are there any x values that miss the graph? Does this one miss the graph? No, where does it touch it? Way up high. And the further left I go, the higher the graph is going to be. Over here on the right side, same thing. So what is the domain? All real numbers. All real numbers. Now if I turn this, oops, not that. So I'm going to turn this so it hits the y-axis. Are there any y values that miss the graph? Yes, where are they? From -1 down misses. So my range is going to have a lowest number at where? -1. So my range is -1, and how high does it go? To infinity. Does everybody understand that? Eric, you get it? Okay. So now we have to split the graph into increasing and decreasing. This piece is increasing, and this piece is decreasing. What is the number where the graph switches from increasing to decreasing? Negative, these are x values. -3 is the switch, right? X equals -3 is where it switches. So if we look at this red portion, what is the smallest x value for the increasing piece? -3. So it's increasing from -3 until infinity. Is -3 actually increasing? If you were to drive a car down that parabola to the bottom and back up, when you're at the bottom, are you facing up the hill or down the hill? Straight. So do we include -3? No, because it's not going up, it's actually flat, and we never include infinity. All right, that blue portion of the graph represents when we are decreasing. What is the smallest x value for the decreasing piece? -infinity. And how high does it go to -3? Okay. Positive is a little bit tricky. This piece here is positive, and this piece here is positive, which means this piece down here is negative. Where does it switch from positive to negative? What x value switches us from a positive y to a negative y? -4. Where does it switch back from negative to positive? -2. So it changes at the two roots. There are two positive pieces, so we're actually going to write a union. On the left piece, what is the smallest x? So in this piece here, how low do those x's go? To -infinity. how big do those x's get? From the root, right? It's positive until it hits the root, and then it switches to negative, and the root is negative 4. Then it's negative for a while. Where does it switch back from negative to positive? At the other root, which is negative 2. And how long does it remain positive? To infinity. Any questions there? Okay. Well, negative is pretty simple. Remember, it's this piece down here. Where does that graph become negative? After negative 4. How long does it remain negative? Till negative 2. Now I want to point a couple things out. Okay, if we divide our parabola in half, that is the x value that changes from either decreasing to increasing or increasing to decreasing. Look here. Do you notice a pattern between the increasing and the decreasing? So they've been flipped, and there's one other change. So if I told you that it was going up from 4 to infinity, could you tell me where it's going down? Well, look at these. What's the difference between those two parentheses? The 3 and the infinity switched, and it went from negative infinity to positive infinity. So if I'm going up from 4 to infinity, then I must be going down from negative infinity until 4. Okay? Do you notice a pattern there? So the right side of that left piece and the left side of the right piece describes the negative portion. So if I told you that it was positive from 1 to 3, could you tell me the negative? It would be negative infinity to 1, and then from 3 to infinity. So if you have part of the information, you should have enough to fill in the rest, or at least you can double check to make sure that you're doing it correctly, because those patterns are always going to happen. The increase and decreasing, you just switch the x and y and change the sign on the infinity. With the positive and negative, this number will always match that number, and this number will always match that number. Unless, of course, it doesn't touch the x-axis. For instance, where is that negative? Nowhere. Where is it positive? Everywhere. Well, what if we had this? Where is that positive? Is it actually positive at negative 2? No, it's on the axis, so that doesn't count. So this would be never positive, but it's negative from negative infinity to negative 2, union 2 to infinity. Because it is negative 2 to infinity, because it is not positive at negative 2. But there's a faster way to write that. We could just say all real numbers, but x is not allowed to be negative 2, which means everywhere but negative 2 it's negative. Okay. Go ahead, work on that. I'll put the answers up on the board. And then after you work for a while, I'm going to start recording again, and I'll show you how to answer the last problem.